Hi everyone. Today I'm going to be doing questions 1 and 2 from exercise 1.9, and that's from your JAC Plus textbook. So what you want to be doing as you're working through the modelling and applications exercises is to just be doing a couple each day. It's not a good idea to do them all in one go. So let's take a look at the first one. So they've given us a little table of data points. So here's our table of data points, and here are x values and y values, and they're asking us discuss why neither a linear, trigonometric, exponential, nor a power function in this form is likely to fit the data. Okay, well, I think a good first step would be to see what that might look like if you were to plot it. So I'm going to do just a quick little sketch, and I'm going to make that as accurate as I can without, using graph paper. So 0 for x and 4. So let's say that's 0, 4 here. We've got 1, 2, so somewhere about halfway down. 3, 10, so something pretty high there. So it's a bit weird, that one, for a couple of reasons. I guess it sort of skips from 1 to 3 for our x values, and also there's quite a massive jump there. And we've got 4, 8. 1, 2, 3, 4, 8. So let's put that somewhere here. So if I'm to connect that up, which, well, it may or may not be connected up, but let's see. So it might look something like that. So immediately you can see that that's certainly not a linear relationship. Even if we were to draw some sort of regression line there, it doesn't really look like it's going to fit linear. So I can see that it's not linear. So let's write, I guess, linear. No. It's not a one-to-one function, we could say. And I guess that would also take care of the exponential. So remember, exponential is something like this, or, it could be the negative form of that. That's not one-to-one either. So I guess for the same reason. So we could say those, and the values are sort of jumping around a bit there too. Trigonometric function, I mean, it would probably be the best of the 3 so far, but I'd say it's not really, because it's not cyclic. It just sort of has 4 points, and it's not repetitive. So trig, I'd say no, because it's not cyclic. It doesn't oscillate. What's next? Exponential. Well, we've already covered exponential. Well, power function. So I guess it could be a power function. It could be a polynomial, but they're giving us a specific form there. So if that was x to the power of 2 or 3, or obviously not 2, but just say x to the power of 3 or 4 or something like that. But it could not be in that form because, well, look, the y-intercept is not 0. So the y-intercept of this would have to be 0. And this is not 0. So I think we've covered all of them there. So discuss why neither linear, trigonometric, exponential, or power function likely to fit the data. Yep, so that's fine. Moving on. So now with those data points, they're telling us to assume that it fits a hyperbola. So here's our hyperbola rule there, which is quite nice. You would know that rule anyway. But they've given it to us. Use the data to determine the equation of the hyperbola. All right, so as per usual, if we're determining equation, we will sub in some values. And your best bet is to take the easiest values. So I'm going to take 0, 4. So that's going to give me 4 equals a over x is 0 minus 2 plus k. And let's see, 4 equals a over neg 2 plus k, and then I'm going to multiply everything by negative 2. So you can leave it like that if you want, but it's not really easy to work with. This is using technology, so you would do it on CAS. You could do it easily on CAS. I'm just going to do it by hand because I feel like it's not really that difficult. We can do it by hand. So this would be my first equation. I'll just neaten that up. A minus 2k equals neg 8. And the second equation, well, let's just sub in another fairly easy point. And how about 1, 2? So that's going to be 2 equals a over 1 minus 2 plus k. 2 equals a over 1. no, -1, sorry, plus k. And then like the other one, I'm just going to times everything by -1. So I'm going to get a minus k equals -2. So this would be my second equation. So now, just like from back in year 9, you can, subtract or add those equations there because they are simultaneous. So a minus a will cancel the a out, can go. -2k, be careful with negatives, minus -k. So that's going to be plus, it'll turn to a plus. -2k plus k is -k equals -8 minus -2. So -8 plus 2 equals -6. And that means k equals 6. So we've got our k value. Let's sub back in to the easiest equation. So I'm going to take this one, equation 2, and it's going to be a minus 6 equals -2. So a equals, adding 6 on both sides, equals 4. So now I've got my values for a and k. Well, now I can state the equation quite easily. So that's going to give me y equals, was it y or was it f of x? Y. Y equals a, which is 4 over x minus 2 plus k, and k was 6. So there's my equation. So I'm going to just highlight that or box it so that it's easier for the person marking to find your answer and hence give you the mark. So we've used the data to determine the equation. Now they want us to sketch it showing the data points. So let's do that. I'm just going to make that a bit smaller and I'll put it over here. Right, so, oops. Okay, so let's have a look. If I sketch this hyperbola, we know that we have asymptotes for that, and the asymptote will be at x is positive 2. And another asymptote at y equals 6. So by now you should be pretty good at drawing all, or sketching I should probably say, sketching all your graphs. And it will be like this. And it will be like this. And let's put the points on now and we'll see that they will actually fit the data. So the first point is 0, 4. So I'm going to put that here. And actually, to be more accurate, I don't have data going in the other way. So, I don't have any data going out towards the negative x value set. So it stops at that 0, 4. And I should label that because it says showing the data points, 0, 4. Oh, there we go. Oh, goodness. And now what's our next one? 1, 2. So let's see, 1, 2. Let's pop it there. And then they're the data points we use to form the line. So they will be for sure on there. The next one is 3, 10, and you can check that out. If you don't believe it, you could sub in 3, 10, and you will find that that does lay on that line, on that curve. So 3, 10, if x is 3. So we get 3 minus 2 is 1, 4 divided by 1 is 4, 4 plus 6 is in fact 10. And our next data point at 4, 8, so I'm going to put that there. And again, 4 minus 2 is 2, 4 divided by 2 is 2, 2 plus 6 is 8. So yes, that does lie on there. Now you'll notice I do put my, my arrow on this end to continue down there, and I put my arrow here to continue here because, well, we're skipping the 2 value, so we don't know what happens there. But here I probably should cut that there as well. So that will be my sketch. Okay, so that takes care of question 1. Let's look at question 2. So the population in thousands of bees in a particular colony increases as shown in the table. Okay, plot the data points P against T and suggest a likely model for the data. So it would be nice if we did it on graph paper, but you can, you could draw it on your CAS, or really, we'll just sketch it here. I think the important part is not so much drawing it, but finding your equation for it, which I'm sure they'll ask us. Yes, they will ask us to find a rule. So let's see. We have up to 4 months. So 1, 2, 3, 4. 0, and then we go in tens of thousands, or in thousands, sorry. So I'll call this P in thousands. and I'll call this t. So my first point is 136, so I'm going to put that somewhere here, and I'm going to label it. And the second point, 238.75. And the next point is going to be 342.5. Oh, I haven't left much room there. Let's put it here. And of course the last one, 445, so let's put that here. And if we were to connect those lines, we wouldn't be able to connect it with a ruler. So even if you did it on graph paper or with your CAS, you wouldn't. But you can kind of see that it moves pretty much as a straight line. And we can say this, if we were to put this regression line in, it would be linear. So I would say the likely model would be linear. So let's see. They now want us to form a rule for the model, and they've given us two specific values to use here. And it's important we use the ones they say because, well, as we saw, these dots do not make a perfect linear relationship. So if we use other ones, we're going to get a different equation. So let's see, y equals mx plus c, but in this case we're using p for population because that's what they tell us, equals mt instead of x plus c. Be careful with your variables, you lose a mark if you use the wrong ones. And now, as usual, we would find the gradient, which is y2 minus y1 over x2 minus x1. Of course, it would be p2 minus p1 over t2 minus t1, but for the sake of just showing the equation there, I'll put that. And then I can say 45 minus 38.75 over 4 minus 2. And let's see, so I'm just going to quickly CAS that. 6.25 over 2. And that gives me that my gradient value is going to be 3.125. So far I have P equals 3.125 T plus C. And the last thing I need to do is find the value of C. Now notice you could use the alternate formula for the straight line equation, y minus y1 equals mx minus x1. I always like to use this one, but either way is fine. You will get the same thing. So now we need to solve for C, and we're going to sub in a point. So they've told us the 2 points that we're allowed to use. So I'm going to choose this one only because it does not involve any decimals. So it's a little bit easier. But you'll get the same value if you use the other point. Just make sure you use one of the highlighted ones. So the point we're subbing in to find that C value is 445. So it's 45 equals 3.125 times 4 plus C. And I'm just going to solve on CAS using my solve function, comma C. Well, I'm going to use an X, but if we were using C. And okay, so I'm getting C equals 65 on 2, and because we're dealing with decimals, that's 32.5. So we can leave it as decimals in this case. Notice that most times for methods we use fractions, we do not use decimals. So our equation is going to be the population is 3.125 times the time plus 32.5. So it's a little bit long-winded there, but that is our equation. Again, I'm going to highlight it or box it or write it in red, something, so it's easy for the person marking it to find your answer. So we've got our rule. I'm just going to write that here. P equals 3.125T plus C, and that was 32.5, I believe. Yes. Okay, so now I can see that, so we can use it. All right, so part C tells us if the variable T measures the number of months since January, how many bees were in the colony in January? Okay, so that means this must be February, March, April, May. So in January, well, T must equal 0. In January, T equals 0. So we can just simply sub that in. P equals 3.125 times 0 plus 32.5, and that means the population is 32.5. Now be careful because this is thousands of bees. So you're going to be multiplying it by 1,000 then. So, well, let's do that. And think it sounds ridiculous if you have 32.5 bees there. So it's quite obvious that something's wrong. And then you can look back and you can see that the population in thousands. So 32, jump your decimal point 3 times, 500 bees. All right, so let's move down. And the last bit, I think, yes, this is the last bit. The population on Earth, same thing, in thousands of bees in a particular colony increases as shown. What is the rate of increase? So this word rate and rate of increase, that directly refers to the gradient. So what it's asking us to do is to interpret the gradient. And while it's not too bad, what we will say is that the gradient is 3.125. And remember that it's times 1,000. Everything's times 1,000. So let's times that by 1,000. So that means 3,125 bees per, and we look and we see that our t value is in months. And it means because the gradient is positive, it means we're increasing by 3,125 bees per month. And if you look at the graph that we drew up there, well, that's obvious because we've got a positive slope or a positive gradient there. So we can say the population increases by 3,125 bees per month, and that would be our answer. So that completes the first 2 questions from 1.9, and I will be making a video for the next 2 tomorrow. Bye.